Hey everyone, welcome back to Electrology, your friendly companion for electrical engineering concepts. Today, we're going to talk about a very practical and crucial topic: economic choice of transmission voltage. This is one of those things that seems simple at first, but has a lot of engineering logic behind it. So, let's dive straight into it. We know that when the transmission voltage is increased, the amount of conductor material required gets reduced. That means we can save money on the conductor material. So naturally, it feels like using the highest possible transmission voltage is the best way to reduce costs. But it's not that simple. As transmission voltage increases, the cost of insulating the conductors also rises. On top of that, the cost of transformers, switchgear, and other terminal equipment also starts increasing. So, there's a point, a particular voltage, beyond which increasing voltage doesn't give you more savings. Instead, it just adds to the cost. This ideal voltage, where the combined cost of everything, conductors, insulators, transformers, switchgear, and terminal equipment, is at its lowest, is what we call the economical transmission voltage. To find the economical transmission voltage, we assume that we already know the power that needs to be transmitted, the generation voltage, and the length of the transmission line. Then we pick a standard transmission voltage and estimate the various costs involved. Now here's what happens. The cost of transformers at both the generating and receiving ends increases as we raise the transmission voltage. Switchgear also becomes more expensive with higher voltage levels. Lightning arresters are another cost that goes up significantly with the increase in voltage. And then insulation and mechanical supports. These too become more costly as voltage rises. But interestingly, the cost of conductors shows the opposite trend. As we increase transmission voltage, we need less conductor material, so that cost actually goes down. Now, when we total up all these costs, transformer, switchgear, lightning arrestor, insulation, and conductor, we get the overall cost for that particular transmission voltage. If we repeat this process for different voltages and plot the results on a graph, we get a curve. On this curve, there's a point, let's call it point P, where the total cost is minimum. That point corresponds to the most economical transmission voltage. In the graph shown on the screen, this minimum cost point is represented by P, and the corresponding voltage is shown as line OA. This method sounds straightforward, but in real-world practice, it's rarely used. That's because it's hard to get accurate and reliable cost estimates for all these components. These days, instead of calculating everything manually, engineers prefer to use empirical formulas to estimate the economical transmission voltage. One such formula is used in American practice for a three-phase AC system. It goes like this. Voltage equals 5.5 multiplied by the square root of 0.62 times the distance, plus 3 times the power divided by 150. In this equation, voltage is the line voltage in kilovolts. Power is the maximum kilowatts per phase that will be delivered through the circuit. Distance is the length of the transmission line in kilometers. Now, what's important to note is that both the distance and the power to be transmitted have a big influence on this economical voltage. If the transmission line is long or the power is high, then more expensive terminal equipment is required. So, increasing the voltage helps bring down those terminal costs. That's why for transmitting large amounts of power over long distances, higher voltages are preferred. It reduces the cost per kilowatt of the terminal station equipment. And that wraps up our discussion on economic choice of transmission voltage. I hope this video helped clarify how we strike the perfect balance between cost and voltage in power transmission systems. If you learned something new today, don't forget to like this video, share it with your fellow engineers, and of course, subscribe to Electrology for more high-voltage learning. Also, drop your thoughts in the comments. I'd love to hear what topic you want us to cover next. And hey, if you really want to support this channel, hit the thanks button or join as a member for exclusive content and perks. Thanks for watching, and I'll catch you in the next one.